So we'll get started with the review for exam number 2. And in this case, we're going to look at problem number 1, which says here the ozone level in parts per billion on a summer day in a certain metropolitan area is given by P of T is equal to 20 plus 8T minus T squared, where T is the time in hours and T equals 0 corresponds to 9 a.m. And in part A, you're going to use the 4-step process to find P prime of T, and then you're going to find P of 3 and P prime at 3. So here's P of T, and that's equal to 20 plus 8T minus T squared. In part A, they want to use the 4-step process. That means you start off with P of T plus H. That means you'll substitute every T with the T plus H. So that means I'm going to have 20 plus 8 times T is replaced with T plus H minus T squared. That T will be replaced with T plus H, and that's squared. Okay, now here we're going to have to simplify this algebraically. So but if I bring down the 20, distribute the 8 over the T plus H, I would get what?
18 plus 8H.
Okay, and then minus, I'm going to put this in parentheses here. And somewhere off to the side, I'm going to do T plus H quantity squared. And write this as T plus H times T plus H. And use the FOIL method. So that means here, T times T, T squared. T times the H, I'm going to write this as HT. Just writing the letters out in order. H times T would be another 8 plus HT, plus H times H would be H squared. Combine like terms, how many HTs do I have? 2 of them. So this would be T squared plus 2HT plus H squared. So that's what T plus H quantity squared would be. T squared plus 2HT plus T squared. And then if I distribute that negative over the T squared plus 2HT plus H squared, I bring this down. Everything in the parentheses changed to the opposite sign, so I'm going to have a minus T squared, and then a minus 2HT, then a minus T squared. I mean H squared. Yeah, that H squared. So this is H squared, and this is H squared. Okay, so that part right there is step number 1. Now, step number 2 is doing this, P of T plus H minus P of T. Well, we've done P of H plus T, which is all of this right here. 20 plus 8T plus 8H minus T squared minus 2HT minus H squared. And then we're going to subtract from it what P of T is. 20 plus 8T minus T squared. Notice that's in parentheses. And then if I distribute, that 20 becomes minus 20, plus 8t becomes a minus 8t. This should be plus t squared, but then it's going to become minus t squared. And then if I combine like terms here, these 20s are gone. Your minus t squared and plus t squared. Hold up. I'm sorry. This is right. Because this was minus t squared from the beginning, but when I distribute the negative, it's going to be a plus. Okay, because that minus t squared and that plus t squared has to go. Let's see, minus 8t and plus 8t are gone. There should be nothing left but terms that have an h in them. So in this case, I have 8h minus 2ht minus h squared. So that's step number 2 right there. Now, step number 3 is taking that p of t plus h minus p of t, dividing all of that by h. So p of t plus h minus p of t, that's this part right here, the 8h minus 2ht minus h squared. All that's divided by h. Now, in the numerator, what can I factor out? What term can I factor out in the numerator? An h. So if I factor out that h, I'm going to be left with 8h divided by h, which will be 8, minus 2ht divided by h will be 2t, minus h squared divided by h will be h. All that's divided by h. Those h's divide out in the numerator and the denominator. I'll be left with 8 minus 2t minus 8, h. So that was step number 3. And finally, step number 4 is taking the limit as h approaches 0 of that p of t plus h minus p of t.
There's no other way to break these problems down.
That's it. You only got one of these. The rest are going to be easy.
So then we're gonna be working more.
Yeah, probably. Because you have to use the definition. Yeah, because you have to use the definition of the derivative to do this type of problem. The rest are just going to be just basic rules.
I have a question.
Yes.
Are you posting this in Canvas?
Yeah, we post
Yeah.
all of them in Canvas.
Yeah.
Is your voice gonna be over it?
Yes.
Yeah, we do it too.
Mm-hmm.
It helps me.
We're live right now.
Watch.
Okay.
We're gonna go?
All right. All right. So now let's finish. Okay, let's finish this. All right. H going to 0. H approaches 0. Well, this we can do direct substitution here. 8 minus 2t. H will be replaced with 0. So you'll end up with 8 minus 2t. And that's all there is to it. Okay.
So let's A, B, C.
That's just part A. Steps 1, 2, 3, and 4.
Oh, wow.
Part B is just substitution.
Yeah.
Because notice in part B it just says find P of 3 and find P prime of 3. So in part B, P of 3. That means T is equal to 3, so that means we take that original function that we have, P of T, substitute every T with 3, and simplify. So for P of 3, this is going to be 20 plus 8 times T, which is 3, minus T, which is 3, and that's squared. All right. 8 times 3, that's going to be 24. Minus 3 squared, that's 9. And what's 20 plus 24 minus 9?
35.
35. So that means the value of that function when p is equal to 3 will be 35. Now p prime of 3, well, let me write down what p prime of t is. That's at 8 minus 2t. So p prime at 3, all you do there is just substitute the t with 3. So 8 minus 2 times 3 is 6, was 8 minus 6? 2. So the value of that first derivative when t is equal to 3 is going to be 2. Okay. Any questions about problem number 1, A and B? Now number 2 is finding the derivative dy dx for y is equal to x to the 10th power. Get past the hard ones. This one's going to be these are the easy ones right here. Okay, so with okay. So dy dx. Here we have to use the power rule by bringing the power down, copying the variable over to the one less power. So what would be the derivative with respect to x of x to the 10th power? 10. X to what power? 9. Bring the 10 down, copy the x over to the one less power. 10 minus 1, that's 9. That's all there is to it. That's the answer. Okay. All right. All right, number 3. Let's say I want to find dy dx for, in this case, y is equal to x to the negative 9 power. Y equal x to the negative 9 power. And here dy dx is going to be okay, so the derivative here would bring the negative 9 down. That's the power. Copy the x over to the one less power was negative 9 minus 1. Negative 9 minus 1.
Oh.
Negative 10. Okay. And you can leave it like this, negative 9x to the negative 10 power. Or you could write it as 9 over x to the positive 10. Okay, questions on number 3. All right, number 4, we got g prime of x, and we have g of x is equal to x to the 4/5. G prime of x, and that's equal to x to the 4/5. I mean, g of x equals x to the 4/5. We want g prime of x. Okay, so again, using the power rule, we need to bring the exponent down, which will be what, 4/5? Copy the x over to the one less power. What's 4/5 minus 1? Negative 1/5. Okay, and if that was hard for you, you can do this in the calculator by doing 4 divided by 5, then minus 1. Press the math and number 1 for fraction. That would give you the negative 1/5.
How do you get the fraction again? I'm sorry. Is it?
4 divided by 5 minus 1. Math key,
Okay.
number 1. Any other questions? All right, number 5. Now we get f of t is equal to negative 5t squared minus 4t plus 2. f of t is negative 5t squared minus 4t plus 2. And here, let's find out what f prime of t is going to be. So what would f prime of t have to be?
So we got two
2 times that negative 5, which is negative 10,
t,
t to what power?
well,
To the 1, or we can just say negative 10t, minus the derivative of 4t is,
negative 5 t.
Mm.
Just negative, wait, no, it'd be just t. It'd just be 4.
just be 4, minus 4. So it'd be negative 10t minus 4. And the derivative of 2
0.
is 0. Okay? All right, questions on number 5. All right, number 6, we got h of t is equal to 5 over t to the 1/2 minus 6 over t to the 2/3. And I want to find its derivative. I'm going to rewrite this as 5t to what power? It's in the denominator. It'd be negative 1/2. Then minus 6, and then that t to the 2/3 in the denominator. If I take that out, it'll be t to what power? Negative 2/3. Okay, using the property for negative exponents. If you take an exponent out of the denominator, it changes to the opposite side. So I have h of t is equal to 5t to the negative 1/2 minus 6t to the negative 2/3. And now let's find out what h prime of t would be. Using the power rule, if I bring the power down, negative 1/2 times 5 would be
5 over 2.
okay, and it'd be what? Negative 5 over 2. Then you copy the t down to the negative 1/2 minus 1 is what?
Negative 3 over 2.
Negative 3 over 2. And then minus, for the derivative of 6t to the negative 2/3, if I do negative times this negative, that's going to change to a plus. Plus how much? 6 times 2/3. What's 6 times 2/3? 4. Copy the t over to the negative 2/3 minus 1, which will be what?
Negative 1.6.
As a fraction.
130.
Um,
Would it be negative 5/3? Okay, here you go. Negative 2 divided by 3 minus 1. Press the math key and then number 1 for fraction. It'll give you negative 5/3. Okay. Are there any questions about problem number 6? All right, number 7. There are 4 parts to this. In this case here, we're going to find the following for f of x equals 3x to the 4th minus 8x cubed plus 4. First of all, we need f prime of x, and then we need to slope the graph of the function at x equals 3, and then find the equation of the tangent line at x equals 3, and then find the value of x where the tangent line is horizontal. So problem number 7 Here we got this function f of x is equal to 3x to the fourth minus 8x cubed plus 4. So let's start with part A. Finding f prime of x. So the derivative of 3x to the fourth would be 4 times 3, which is 12. Copy the x down to the 4 minus 1, which is, what's 4 minus 1? 3. Minus the derivative of 8x cubed. Bring this 3 down. 3 times 8 would be 24. Copy the x down to the 3 minus 1, which is 2. Derivative of 4 is 0. So that's what f prime of x is. 12x cubed minus 24x squared. So that's part A. Part B is finding the slope of the graph of the function at x is equal to 3. In other words, we're finding the slope of the tangent line at x equals 3. So that means we just do our substitution in the f prime of x function. Substitute the x with the 3. So this will be 12 times x, which is 3, and that's cube, minus 24 times x, which is 3, and that's squared. Now I'm going to go ahead and do all of this in the calculator here. 12 times 3, and then the hat key, 3 for the exponent of 3, minus 24 times 3, and then x squared to square it. And then hit enter. So that means that the slope of the tangent line at x equals 3 would be 108. That 108 represents the slope of the tangent line. So that's part B. Part C is the equation of the tangent line at x is equal to 3. Well, at x is equal to 3, we need to find out what that y coordinate is going to be. We first substitute the x with 3 in the original f of x function. So I have 3 times x, which is 3, and that's going to be to the fourth, minus 8 times x, which is 3, and that's cube, plus 4. And again, I'm going to do that in the calculator as well. I'm going to do 3, and then left parentheses 3, close parentheses. That will be to the fourth. Right arrow to get out of it. Minus 8, left parentheses 3, close parentheses. Then the hat key for the exponent, and then 3. Right arrow to get out of it, plus 4. That would give me 31. So my ordered pair would be 3 and 31. And I'm going to use the slope of the tangent line, which is 108, in my point slope form, which is y minus y1 is equal to the slope of the tangent line, m, times x minus x1. So that 3 would be x1, 31 would be y1. So y minus y1, which is 31, is equal to the slope of the tangent line, that's 108, times x minus x1, which is 3. So I have y minus 31 is equal to, distribute the 108 over the x minus 3, I would get 108x minus 108 times 3, which is 324. And then to solve for y, I'll add 31 to both sides. So that means y is equal to 108x. Now, what's negative 324 plus 31? No, it's got to be negative.
And this is still the slope? This is still the slope?
No, that's the equation of the,
Okay.
that's the equation that we're looking for. So in this case here, the equation of the line tangent to the point at x is equal to 3, or tangent to the curve at x equals 3 would be y is equal to 108x minus 293. Okay. Are there any questions about part C? And of course, part D is the value of x where the tangent line is horizontal. That means that your derivative, f prime of x, has to be equal to 0 for it to be horizontal. That means the slope has to be 0. And f prime of x came out to be 12x cubed minus 24x squared. And that's equal to 0. Now, let's see here if we can factor out something out of 12x cubed and 24x squared. What can be factored out in both of those terms?
X 12x squared.
12x squared. So if I factor out the 12x squared, 12x cubed divided by 12x squared, I have an x minus 24x squared divided by 12x squared would just be 2. And then we set each factor equal to 0. So that means that 12x squared is equal to 0. X minus 2 is equal to 0. Well, for the 12x squared equal to 0, if I divide both sides by 12, that means x squared would be equal to 0. And what number squared will give you 0? Has to be 0. And then for the x minus 2 is equal to 0, x has to be equal to 2. So I get two values of x where the tangent line is going to be horizontal at x equals 0 and at x is equal to 2. Okay. Are there any questions about problem number 7? All right. Let me see if I can do problem number 8 over here. It says here, okay. It says here, find the indicated derivative, which is the derivative with respect to x of 11x plus 31 divided by x. What I'm going to do here is take the 11x and the 31, divide each one of them by x. So this will be 11x divided by x plus 31 divided by x. So in this case, the derivative with respect to x, well, 11x divided by x would just be 11. That 31 over x, I'm going to write that as 31 times x to what power?
-1.
-1. Now let's go ahead and take its derivative here. The derivative of 11, of course, is 0. And the derivative of 31x to the -1,
-31.
-31, x to what power?
-2.
-2. Now you can leave it like this, or if you want to, you can just write this using positive exponents as 31 over x squared. Because if we put the x squared to the -2 and the denominator changes to a positive 2, so it'll be x squared in the denominator. Okay. Questions on problem number 8? Now, in problem number 9, they want you to find dy for y is equal to 35 plus 8x squared minus x cubed. This one, those are this deals with just differentials. You'll take the derivative of this and then you'll include dx on the end. So if this is what y is, then dy would be the derivative of this times dx. So the derivative of 35 plus 8x squared minus x cubed. Well, what's the derivative of 35?
0.
0. The derivative of 8x squared?
16x.
16x minus the derivative of x cubed?
3.
3x squared. And I will include dx on the end. That's all there is to it. So that's how we find that differential. All right. Any questions on problem number 9? Now, problem number 10. Here we got y is equal to f of x, which is, of course, x to the 4th minus 7x cubed plus 3. They want us to find dy and delta y given x is equal to 5 and delta x is equal to negative 0.2. So we're given x is equal to 5, and also we're given delta x, which means a change of x, equaling to negative 0.2. So let's first find out what dy is going to be by taking the derivative of each and every term here and then put dx on the end. So the derivative of x to the 4th will be what?
4x to the 3rd.
4x to the 3rd, and then minus the derivative of 7x cubed.
21x squared.
21x squared. And then we're going to include dx. All right, so that's what dy is going to be. 4x cubed minus 21x squared dx. Now we are told that x is equal to 5 and delta x is equal to negative 0.2. But this delta x also means dx. So dx will be negative 0.2. Now let's substitute those values into dy. So that means dy is equal to 4 times x, which is 5, and that's cubed, minus 21 times x, which is also 5, and that's squared, times dx, which is negative 0.2. I'm going to simplify what's inside this first set of parentheses. All right, so I got 4 times 5, and that's cubed. I'm going to write L to get out of it, minus 21 times 5, and then hit x squared to square it. That part is negative 25. But I got to do negative 25 times negative 0.2. dy ends up being 5. So that's what dy is. It's going to be 5. We also have to find delta y. And here, delta y, that represents a change in y, which is going to be, you might have to look through your notes for the section on differentials here, f of x plus delta x minus f of x. That represents a change in y. I'm going to bring down delta y and replace the x with that 5, plus that delta x is negative 0.2 minus f of x, which is 5. And what's 5 plus a negative 0.2?
Positive 4.8.
Positive 4.8 minus f of 5. And I'm going to evaluate somewhere off to the side, somewhere, f of 4.8. Using this function right here, I'm going to replace every x with 4.8. So this will be 4.8 raised to the 4th minus 7 times x, which is 4.8, and that's cube plus 3. And this can be done in the calculator as well. So I'm going to clear this out, 4.8, close parentheses, and to the 4th would be that hat key, and then the 4, minus 7, left parentheses, 4.8, close parentheses, press the hat key, and then that's cube, right arrow to get out of that, and then plus 3. So this is what f of 4.8 would be, negative 240.3024. And now f of 5. So I know I got 5 raised to the 4th minus 7 times 5 raised to the 3rd plus 3. Using the original function, I'm substituting the x with 5. So this will be 5 to the 4th. And get out of that using the right arrow key, minus 7 parentheses 5. And then that's going to be cubed. Right arrow to get out of that, plus 3. Here I'll come up with a negative 247. So to simplify this, f of 4.8 was negative 240.3024 minus f of 5, that's negative 247. Okay. So if I do negative 240.3024 minus a negative 247, I'm going to end up with
6.6976.
okay. So delta y would be 6.6976. Okay. All right. Are there any questions about problem number 10 and how that's done? Okay. Problem number 11 is this. An egg of a particular bird is nearly spherical. The radius to the inside of the shell is 9 millimeters, and the radius to the outside of the shell is 9.4 millimeters. Use differentials to approximate the volume of the shell. And you're told that the volume with respect to r is going to be 4/3 pi r cubed, where r is the radius. So that's already given to you in that problem. So V of r in this case was 4/3 pi times the radius cube. So the first thing I'm going to do is find out what its derivative here is, v prime of r. Now keep in mind the 4/3 and the pi are constants. I'll bring that down. What's the derivative of r cubed?
3r squared.
3r squared. And of course, if I simplify this, those 3's divide out, I'm only going to be left with 4 pi r squared. 4 pi r squared. Now let's look at what we already have here. If I want the change in r, that means the radius to the outside of the shell, which is 9.4, minus the radius on the inside of the shell, that's 9. What's 9.4 minus 9? 0.4. Okay, so that's what delta r is. It also means that dr is going to be 0.4. And also I know this, dv, the derivative of v, would be v prime of r times dr. And we found out what v prime of r is. That's that 4 pi r squared. And it'll be multiplied by dr. Now let's do our substitution here. This will be 4 pi times the radius. In this case, the radius was 9. And that's squared. Times dr was 0.4. We found that out to be 0.4, so let's go ahead and substitute that as well. Let's see, I'm going to do 4. The pi is right above this hat key, so if you do second and the hat key right below the clear key, you should get pi, second hat for the pi. And then times 9, and then you square it, times 0.4. And I'm going to round this up to 2 decimal places, so this will be 407.15. And this is in cubic millimeters. Okay. So that's all there is for problem number 11. Okay. Are there any questions? Okay. All right, number 12. Here we're going to find the marginal profit function if cost and revenue are given by this. C of x is equal to 159 plus 0.7x and R of x is equal to 5x minus 0.01 x squared. All right, marginal profit. Let's start with this. The profit is always going to be revenue minus the cost. Let's start with that. Let's find out what that profit function is and then take the marginal profit, find out what the marginal profit function is by taking this derivative. Well, the cost, the revenue they give you as 5x minus 0.01 x squared minus the cost. And the cost was 159 plus 0.7 x. Okay. Now, I can write this without the parentheses, but that minus sign makes 159 minus 159, and the minus sign makes a plus 7.7x minus 0.7x. And then we're going to combine like terms here. I'm going to put the negative 0.01 x squared in front, but what's 5x minus 0.7x? 4.3x. And then minus 159. Now from here, we can take its derivative to come up with the marginal profit function, because marginal means you have to take the first derivative. So the derivative of negative 0.201x squared would be negative 0.0,
X.
yeah, 0.2, negative 0.2x. And then the derivative of 4.3x would be
4.3.
just 4.3. And that's all there is to it. So that is a marginal profit function. P prime of x equals to negative 0.2x plus 4.3. When you're dealing with marginal profit or marginal revenue or marginal cost, you have to take the derivative here of those functions. All right, questions on problem number 12. Okay, problem number 13 is finding the average cost function if cost and revenue are given by C of x is equal to 141 plus 6.3x and R of x is equal to 4x minus 0.09x squared. Now read that problem very carefully because they want the average cost function. So the only thing you want to focus on is just the cost function itself, which is in this case, C of x is equal to 141 plus 6.3x. So when you're finding the average cost, which is C bar of x, that's going to be your cost function divided by x. Which means by C of x, that's 141 plus 6.3x. All that's divided by x. So each term in the numerator will be divided by x. So I have 141 over x plus 6.3x divided by x. Well, the 141 over x, I will leave that as is. But here, the 6.3x divided by x, these x's divide out. You'll be left with a plus 6.3. Okay. All right. Are there any questions about problem number 13? Okay. Number 14, there is part C on the next page, by the way. The total cost in dollars of manufacturing X auto body frames is C of X is equal to 40,000 plus 800X. Part A, you're going to find the average cost per unit if 250 frames are produced. Part B is to find the marginal average cost of at a production level of 250 units. And then part C, which is on the next page, use the results from parts A and B to estimate the average cost per frame if 251 frames are produced. All right, so let's start with number 14, part A. And we're told that C of X is equal to 40,000 plus 800X. In this case here, we're finding the average cost per unit. So that means C bar of X means the average cost. That's C of X divided by X. So we take that cost function of 40,000 plus 800X divided by X. So it'd be 40,000 over X plus 800X divided by X. And as you can see, these X's will divide out here. So I'm left with 40,000 X over X plus 800. And this is where 250 frames are produced. So C bar of 250, we'll take that and substitute the X with 250. So it'd be 40,000 divided by 250 plus 800. How much? 960?
960.
Okay. So that means the average cost of per unit, if 250 frames are produced, would be $960. So that right there was part A. Now in part B, they want, excuse me, they want the marginal cost at production, at a production level of 250 units. So let's use that C bar of X function, which was 40,000 over X plus 800. And I'm going to write this using negative exponents. So this will be 40,000 times X to what power? Negative 1 plus 800. Now C bar prime of X, we take its derivative of this function right here. So the derivative of 40,000 X to the negative 1 would be
Negative 40,000 X.
To-
be negative.
good. Derivative of 800 would be 0. And another way of writing that would be with positive exponents. This would be negative 40,000 in the numerator. Bring that X to the negative 2 in the denominator, it'll be X squared. So that's what I'll use here to find out the marginal average cost of producing at the production level of 250 units. So I do negative 40,000 divided by, substitute the X with 250, and you'll square that. And this can be typed in the calculator. So it'll be negative 40,000 divided by 250, and we square it.
Oh, yeah.
And it's going to be negative.
You're right.
So it'll be negative 0.64. So it's going to be pretty much a loss of like 64 cents for producing 250 units for the marginal average cost. Okay. All right, so that's part B. Part C is continued on the next page, where you're going to use the results from parts A and B to estimate the average cost per frame if 251 frames are produced. So the average cost C bar of 251. The way we do that, it'll be the average cost for 250 items minus C bar prime of X, or C bar prime of 250. So we're using what's in parts A and B. And this should be plus. Cost for 250 items back in part A was $960 plus that negative 0.64. Oops, let me bring this up so y'all can see it. So what's 960 plus a negative 0.64?
959.36.
Okay. So it'd be $959.36. And that we can say the average cost per frame if 251 frames are produced. That'd be $959.36. Okay. Questions on problem number 14? Okay, problem number 15 deals with compound interest, and that's using that natural base E in this case. So here we're going to use calculator to evaluate a to the nearest cent. And here a is going to be 14,000 e to the 0.04 t for t is equal to 7. So here we got a is equal to 14,000 e to the 0.04 t, and here t is equal to 7. Excuse me. So in this case here, we just do substitution here, substitute the t with 7, and use the calculator. So it'd be 14,000 times e to the 0.04 times t, which is 7. So a then would be equal to, we got 14,000. For the e, you do second ln for the e. And then 0.04 times 7. Now we need to round this off to 2 decimal places. So this would be $18,523.82. All right, so it'd be 18,523.82. And that's all there is to it. Okay. Are there any questions about problem number 15? All right. Number 16. Number 16 says recently a certain bank, offered a 10-year CD that earns 2.81% compounded continuously. If $10,000 was invested in this CD, how long will it take for the account to be worth $35,000? And this is compounded continuously, so we know we have to use A is equal to P times E to the RT. And you're told what P is. $10,000 was invested. That's your P. Let's see. The interest rate is 2.81% compounded continuously. But what's 2.81% as a decimal?
0.0281.
Okay. All right. And of course, the amount that we want to reach is $35,000. T is what we're trying to find. So we're going to use that compound interest formula, continuous compound interest formula, A is equal to P times E to the RT, and substitute the A with 35,000. That's going to be equal to the P, which is 10,000, times E to the R, that's going to be 0.0281 times T. Bless you. Now let's go ahead and get that E to the 0.0281 T by itself. We need to do that by dividing both sides by 10,000. So here on this side, I'll have E to the 0.0281 T, and that's equal to 35,000 divided by 10,000 is what? 3.5. Yeah, 35 divided by 10, that's 3.5. Now, since E and the natural logarithm are inverses of each other, I need to do the natural log on both sides. Now, on this side right here, ln of E to whatever my exponent is that exponent. So ln of E to the 0.0281 T will be
0.281T.
right. Then that's equal to the natural logarithm of 3.5. Now to solve for T,
Divide 0.028.
Right. 0.0281. So that means T is equal to, and using the calculator, let's see, press the ln key, 3.5, close parentheses, divide that by 0.0281, and hit enter
44.5.
to one decimal place,
44.5.
44.6.
Oh my goodness. Dang. I'm sorry.
So it's going to take approximately 44.6 years for a $10,000 investment to reach 35%, $35,000 at 2.81% compounded continuously. All right, questions on number 16. All right, let's see, number 17. Here we're going to find f prime of x for the function f of x is equal to -8 plus 3x plus 3e to the x. So this is where we talked about derivatives of exponential and logarithmic functions here. And if I can move this up a bit. So here we got f of x is equal to -8 plus 3x plus 3e to the x. And I want its derivative. So f prime of x, let's just take the derivative of each term one by one. The derivative of -8 is 0. The derivative of 3x is 3 plus 3e to the x. Its derivative is what?
3xe. 3ex.
3e to the x. The derivative of e to the x is e to the x. Here we don't use the power rule for that. We just say e to the x for its derivative, because that's what it is.
That just stays the same.
Okay. Questions on number 17. I'll do number 18 over here, where we got f of x is equal to, this time, -12 times the natural log of x plus 13x squared minus 2. And I want to find its derivative. So f prime of x is going to be this. Well, what's the derivative of the natural log of x?
1 over x.
1 over x. So I'm going to have -12 times 1 over x plus the derivative of 13x squared.
26x.
26x. So if I just simplify this a bit, I'll put the -12 on top, where the x will remain on the bottom, and then plus 26x. So that is what f prime of x will be. -12 over x plus 26x. All right, questions on number 18. Now in problem number 19, you're going to use the product rule to find the derivative of this function. Y is equal to 2x squared plus 3 times 4x minus 5. And it says use the product rule here, so it's telling you what to use here. Because notice this is going to be the first times the second. And then the second is the 4x minus 5. So if the first is going to be 2x squared plus 3, what would be the derivative of the first?
4x.
4x. And then the second is 4x minus 5. So what's its derivative going to be?
4.
4. So that means that dy dx, and I will write this out as first times the derivative of the second plus the second times the derivative of the first. So the first was the 2x squared plus 3 times the derivative of the second, that was 4, plus the second, that's the 4x minus 5, times the derivative of the first, that was 4 x. So that's the product rule right there. So now we need to do some algebra here. Distribute the 4 over the 2x plus 3, you're going to get 8x squared plus 12. And then distribute the 4x over the 4x minus 5, you're going to get 16x squared minus 20x. Yeah, minus 20x. Now let's combine some like terms here. 8x squared plus 16x squared would be 24x squared. The rest is just minus 20x and then plus 12. And that's all I can do with that problem there. So in this case here, dy dx will be 24x squared minus 20x plus 12. Any questions about problem number 19? All right, and finally, number 20. It tells you to use the quotient rule to find this derivative. F of x is equal to e to the x divided by 7x squared plus 6. So you're told to use the quotient rule in that problem. So the top, which is the numerator, that's e to the x, and the bottom, which is your denominator, that's 7x squared plus 6. Well, at the top is e to the x. What's the derivative of e to the x? E to the x. The bottom is 7x squared plus 6. So what would that derivative have to be? 14x. All right. So now, using the quotient rule, f prime of x is going to be the bottom times the derivative of the top. So here's the bottom, 7x squared plus 6, times the derivative of the top, that's e to the x, minus the top times the derivative of the bottom, e to the x times 14x. All of that is divided by the square of the bottom, 7x squared plus 6, and that's going to be squared. So I'm using the rule for the quotient rule. Top times the derivative of the bottom bottom times the derivative of the top minus the top times the derivative of the bottom, all that divided by the square of the bottom. Now, let's see what we can do here. What can we factor out in both of these terms right here? What can be factored out? No. E to the x is in both of them. Let's go ahead and factor that out first. That's easier to do there. Because if I factor out the e to the x in this term, I'll be left with that 7x squared plus 6. And then minus, take this e to the x out, you'll be left with just 14x. So I got 7x squared plus 6 minus 14x, all divided by 7x squared plus 6, and that quantity is going to be squared. And I'm just going to rearrange the terms here in the parentheses. So this will be e to the x times the quantity of 7x squared minus 14x plus 6. That's going to be divided by the square of the bottom, 7x squared plus 6. That quantity will be squared. And I will go no further than this. All right. Are there any questions about problem number 20? Or does anybody have any questions about what is expected on Monday's exam? Number 2.